Uh, Zainab, you can't share the Zoom link with your friends. You can share the YouTube link with the friends. I'll share that. Uh, Zainab, you can't share the Zoom link with the Shh. March 23, questions 5 and 7. Usman, have you gone through the recording already? Because you have access to that, right? March 25 paper, March 23 papers solved. Have you gone through that? Okay, so do you have specific questions from that? Yes, they will be announcing on 7th what their plan is about P1. So yes, so until then, we just focus on M1. Okay, Charan. I've done the setup. Share the link here as well. Okay, Charan. What I'll do is I'll start the screen share and start the session as well. You guys can hear me clearly and also see my screen now, right? Somebody please confirm. Yes. Okay. All right. So in this session, we are going to be I'll first of all answer any general questions that you might have about the exam. That may take around maybe 10 minutes in the beginning, and then I want to get started with some specific questions that you might have problems in. You can bring your questions, any problems that you've got. I'll start with the Zoom people first. Once these questions are answered, then I'll look at the YouTube questions as well after that. Okay. So be patient. Just be patient. All right. Achha. Okay. So first of all, some general things that you should keep in mind about the exam. Uh, so one thing is common about all the papers. Please make sure that you do not get stuck at any particular question. Mechanics is a long paper. M1 is a long paper. It takes time. A lot of times it is really difficult to complete the exam in time. Okay. So you need to manage the time well. I hope you have learned some time management while you were doing M1 yearly exams as well. So it's extremely important that you don't get stuck at a very complicated question in the middle of the exam. Mostly, if you look at the recent papers pattern, it is going to be a question on momentum that has kinematics involved. So you'll have something happening before collision, and then there's a collision, and then there's another motion after that. Those types of questions tend to be the trickiest and they take the longest. Do not get involved with that question and do not get started with that question in the middle of the exam. You should leave that for the end. The easier questions that you find in the exam, like forces and equilibrium, a standard Newton's second law of motion question, a standard work energy power question, you need to save time on them, right? So the standard questions, equilibrium question, are finding the resultant force question in forces and equilibrium. Newton's second law of motion, where you have to find tension and acceleration. Work energy power questions, which are repetitive sometimes, where you use power equals driving force into velocity or resultant force equals mass into acceleration together. You need to save time on those questions that you've seen again and again in past papers. Okay, you need to have practiced those questions. I hope you've done that already, a lot of that. You need to use that practice now to save time on those questions while maintaining accuracy, so that the more difficult questions that you see, apart from those standard questions, there will be two, three questions, they will take relatively longer, and then one question generally that is going to be the hardest. Just make sure that you save time on the rest of the questions. And then on that more difficult questions that you might find in the paper, it's mostly going to be one of the last three questions. The highest probability is of that going to be the seventh question, but sometimes it comes earlier as well as the fifth or sixth question in the exam. Just make sure the questions that you are more comfortable in, the topics that you're more comfortable in, the questions that you find easier, you get done with all of them before you touch that more difficult question. Okay. So that is extremely important. M1, in recent years, tends to be a really long paper, just like P3. P3 is a long paper. It takes, it's hard to manage time in P3 as well. M1 is similar to that. Okay, just keep that in mind. Acha. Now, how much time should you spend on a question before you try to skip it? A couple of minutes at max. So it depends on when you are sure that, okay, you're not able to figure out any direction. So if you're able to figure out a direction that, okay, this is what you could do in this question, and you think you'll be able to do it relatively quickly, as in it won't take a lot of time, you should not skip that. But if you've spent a couple of minutes and you cannot figure out what to do at all, or you have spent a couple of minutes and it looks extremely complicated and you think it's going to take a lot of time, you skip that question. So roughly 1.5 to 2 minutes trying to understand the statement, and that should be fine. That should be it. When you're reading the question the first time, sometimes the question statements tend to be very long. When you're reading the question statement the first time, please make sure that you are underlining important information so you don't have to read the question statement again and again. And the longer statements, you do not want to have to read the question statements repeatedly. So underline all the important information the first time you read it so that you can save time on that as well. Okay. Achha. Now, let me answer some of your questions quickly. Okay, in question 6B of March 26, you did not do any proper working, you just drew diagrams and used the concept when speed was opposite each other, will I get the full marks? In question number 6, part B of this paper, you were saying you just drew diagrams and you did not do any working. What does that mean? Which working did you not do, Aziz? Which of these steps did you not do? So you have to show this 9/6 to find the time from x to y. That step is important. And then 2 into 1.5, and then you write down the displacement. And then these simple calculations that you've got, you should show them. Okay. So these simple additions, multiplications, you need to show them. Yeah, that's okay. So if you just showed this working, sum of what we have here, 9/6 is 1.5, 2 into 1.5 is 3. And then at the end, you found the speed using this. This is important, 6 over 2.5. This step is important. That should be fine. Simplifying resolved forces, or is it all right to use the exact forms in our working? If you're comfortable, so there's a question. When you resolve forces, what happens is you have values in terms of cause and sine sometimes, right? So for example, in this case, we have values in terms of cause and sine after we resolve some forces. Now, should you keep it as cos 30 or write it as a decimal? Avoid writing decimals. If you're comfortable using exact values, that is better, that is ideal. So cos 30, do not use 0.86666, whatever that number, whatever under root 3 over 2 is. I think that's 0.866. Do not use decimals. Cos 30 or under root 3 over 2, they are both fine. In mechanics, a lot of students lose accuracy marks. The reason for that is there are a lot of values in decimals. Since you have a lot of values in decimals, what they do is they end up rounding off values too early, and then by the time they reach their final answer, the final answer is off by one decimal place at the end, and they lose 1 mark because of that. So ideally use exact values. If you do have to write decimals, write a lot of decimal places. Okay, but exact values are ideal, that's better. Okay, should you solve a past paper on the day of the... No, please don't do that. As in your exam is on Wednesday. Do not wake up in the morning and start doing a past paper. Don't do that. If you have to, just revise the concepts once, look at the formulas that you need to remember, because in mechanics, they only give you kinematics formulas. The rest of the formulas are not given, right? So you have to make sure that all the methods, all the formulas that you need to remember, they're fresh in your mind. But otherwise, apart from that, don't do a lot of any practice in the morning. Okay. Acha. All right. Acha, let me answer some of these general questions here as well, and then we start with some specific questions after that.
सर मेरी आवाज आ रही?
जी जी आ रही है.
सर मैं पूछ रहा था कि एक क्वेश्चन था, वो था 23 फरवरी मार्च के ना, क्वेश्चन 4 था।
जी
उसमें
जी.
ना टेंशन, वो कोई एक टॉय।
March 23.
जी जी सर,
So
क्वेश्चन
March
4।
23, let me open that paper quickly. March 23. Can you see that anywhere here? Okay, yeah.
उसमें ना क्वेश्चन 4 में
Question
ना
number कौन सा था?
4 4।
4. Okay.
ये सर, ये जो थी ना टेंशन की वैल्यू में, जो पहले ही ए में थी, ये टेंशन की वैल्यू 0 थी। अब मुझे ऐसा मतलब लगा कि ऐसा तो नहीं हो सकता कि कोई मतलब है कि दो चीज़ें कनेक्टेड हो, उसमें जो है ना टेंशन की वैल्यू 0 आ जाए। और ये पार्ट मैंने स्किप कर दिया, और उसके आगे भी सारे पार्ट से स्किप कर दिए।
हम्म.
तो ये मतलब अजीब सा सवाल है, लेकिन श्योरिटी कैसे आएगी कि ये चीज़ टेंशन की वैल्यू अगर 0 हो, तो मतलब क्या कर सकते हैं मतलब ऐसे में?
As long as you are sure about the concepts, you're confident, uh, वो श्योरिटी उसी से आएगी. अदरवाइज तो अगर आपने प्रैक्टिस बहुत सारी नहीं की हुई है, then you get confused in the exam. अब आपने ये देख लिया, आपने बहुत सारी प्रैक्टिस की, you have seen this case as well, so you know that this is also possible, right? So as long as you're confident in the concepts that you have learned, then if you're applying them correctly, then anything is possible, right? Tension can be 0 in this case as well. Okay. So surety आपके concepts से आएगी. The stronger your concepts are, the more confident you're going to be about that, because uh, otherwise there's no way to know for sure in the exam. That is why I recommend when you do past papers, do not look at the marking scheme after every single question, because that makes you lose that confidence when you are checking your answer after every single question. You will have that urge to do that same thing in the exam as well. You have to do a number of questions in a row and then check the marking scheme at the very end of the end of doing maybe 8 to 10 questions in a row or a whole paper, and then you check the marking scheme at the end. If you have this habit of checking marking scheme out for every single paper, after every single question, that is what makes you overthink in the exam a bit. That happens in permutations and combinations in S1 as well, and also in some of the harder questions in F1. Okay. अच्छा, two blocks वाला questions क्या वो आ सकते हैं when you have one block on top of the other. So if you remember questions like these, uh, forces and equilibrium. No, that was a Newton's second law of motion. So something like this, right? When you have one block on top of another block, and you have to find maximum value of acceleration or maximum value of a force in this case. The last time it came was more than 10 years ago. Yes, so it's very unlikely, but that does not mean it's not possible. Okay, so do not skip any concept thinking it has not been tested for many years, so it will not be tested now as well. That's not a good approach. It has happened to some people, I think, in O levels. Recently, they skipped something that had not come for like 5 years and then it came in their exam. Don't do something like that. As long as it's part of your syllabus, you need to know that. Okay, do not skip any major concept like this. Okay. Acha, we will solve that question. The May June 25 question उस पे आते हैं हम अभी. If you blank out on a long question, first of all, do not touch a very long question in the middle of the paper. But if you have done the rest of the paper and you get stuck at a longer question, you can slow down a little, take 30 seconds, 40 seconds, do some deep breathing, and that helps you relax yourself. And then you can continue with the paper after that. Acha. When they give you resistance in a question, for example, 10 Newton, do we always have to multiply by displacement? Well, it depends on what they're asking about. So if they give you that resistance in a particular case is, let's suppose, 10 Newton. So they give you a value for R that is 10 Newton. Now, if you want to use that in the work energy principle, which is work done by the driving force equals change in kinetic energy plus the change in potential energy plus work done against resistance. Now, this is work done against resistance. So if you want to use this number here, then yes, you would multiply 10 with whatever the displacement is. But if you're using that somewhere else, for example, if you're using that in F equals ma, forward forces minus backward forces equals mass into acceleration. In that case, you'll use 10 as it is. You will not use work, you'll not find work done by multiplying by displacement in that case. So it depends on what you are supposed to find based on that. Okay, so don't memorize stuff like that. Understand the logic behind that. So in this case, we have to use work done. We multiply by displacement. When we put that in Newton's second law of motion, for example, if we have driving force minus the resistance, in that case, we use that same value, which is 10. Okay. Elevator questions. I have a separate video on elevator questions. Just search math prep elevator and you'll find that video. Okay, let me try that. Search math prep and elevator. You will find that video that's specifically on elevator problems. It's, I think, a relatively short video. It should not be very long. Let me find that quickly. Yeah, so it's a 20-minute video. Go through that maybe on 2x or 1.5x, whatever makes sense to you. And you get that, okay? Economics and business papers on the same day as maths? 3 papers in a day? किसकी working? Blocks वाले question की working? Yes, that is there in the crash course notes, I think. Let me confirm that. Yeah, we did that question there, right? Yes, that is there. The block question. Okay. Plus C, when to solve for C? Achha. So there's a question, when do we have plus C? You always will have plus C whenever you integrate something, you will always have plus C. That's the general rule. Whenever you integrate something, you will always have plus C. There is just one exception to that rule, and that is when you're applying limits to an integral. So let me go back there. Kinematics involving differentiation integration. Whenever you integrate something, so when you're integrating velocity and you want to find the displacement function, for example, you will have a plus C there. If you're integrating acceleration and you're finding the velocity function, again, you'll have plus C there. You always have plus C whenever you integrate. There's just one exception, and that is when you're inputting limits. In that case, you're allowed to skip C. When will that happen in mechanics? Only in one case. When you are supposed to find displacement of a particle from one point to another. That is when we use limits. When you have to find the value for displacement from one point to another, that is when you can skip C and you can use limits. Apart from this one case, you always integrate with a plus C and you don't use limits anywhere else as well. Okay. When do we use speed equals distance over time? Speed equals distance over time is used when you have an object going on a horizontal surface at constant speed. Or even on an inclined surface, if it's moving at constant speed, in that case as well, you could say you can use time equals distance over speed or speed equals distance over time. You can use that only when speed is constant. Yes. On a horizontal smooth surface, generally speed is constant, so you can use that. Okay. If you go over all the questions you've done in notes to revise, that covers all standard types of questions. Yes, it does. It'll probably be a better idea to go through the revision videos of the different topics. What I'll do is remind me in the group. I'll share the revision videos notes as well with you guys. Okay, send a message in the group after this session ends. I'll share with you the notes in the revision videos, and in that revision workshop video that I posted, you can go through that, and that covers pretty much every type of question. Okay. Where they give you maximum power and they ask you to find the greatest speed, we must use that maximum value of power. Yes. So in questions where they give you maximum power and they ask you to find the greatest speed, yes, you would assume that the greatest speed would be when the power is at maximum value. You'll use that maximum value. Yes. Okay, that's correct. Can we use graph function and equation solving from calculator? Graph function, you mean the table function. You mean the table function, right? Because graphical calculators are not allowed. Yes, you can definitely use the table function to sketch graphs if you want. You can use the equation solving function on a calculator for quadratic functions if you want, but you have to show working. That's only for verification or finding the answer after inputting values in the quadratic formula. So for example, if you get a quadratic equation, the least amount of working that you would need to show would be that you input values in the formula like this. That's the bare minimum working that you would need to show. Let me see if I can find that anywhere. But I've solved quadratic equation. I'll get the first page there. So when you're solving a quadratic equation, this is the bare minimum working that you need to show. Now, you also need to show this in M1. Okay. Now, sometimes they will have mark for this in the marking scheme. Sometimes they won't have a mark for this. You would not know whether your particular exam in the marking scheme for that, they're going to have a mark for that or not. So you will always show this one single step. And then you can write down the answer after that, and that should be okay. Okay. But this one step is necessary. This one step is necessary. Okay. Time managed नहीं हो रहा, make sure that you do all the questions that you know how to do. So you don't miss out on any question that you knew how to do. Do all of those questions first in the first go. And then in the second go, you try to get as many partial marks that you can in the more difficult questions. If you're if you're well prepared, that should only be maybe one question or maximum two questions, some specific parts, and then that might be problematic. But depending on how well you're prepared, it could be some bigger number for other people as well. But make sure in the first go, you are done with all the questions that you know how to do, and they're relatively shorter, and then spend time on the rest of the questions after that. Okay, S2, unfortunately, I really wanted to start teaching that this year, but I've not got time for that. Maybe next year. I plan every year, but it just doesn't happen, unfortunately. Is showing resolving forces necessary if you don't draw it? It's not necessary, but it's a good idea that you show on the diagram when you're resolving forces, because that will save you from careless errors. If you do everything in your head and write down the working directly from that, it is more prone to careless errors. So if you represent all the forces on the on the diagram, and show what the components are, that will save you from careless errors. Okay, so it's a good idea to show them. They will not mark this diagram. They will not mark this diagram unless they specifically ask in some question to show all the forces acting on an object. Sometimes they do that, but otherwise they will not give you marks for the diagram generally if you have shown any working. But the diagram also helps sometimes if your answer is incorrect. If your answer is incorrect, sometimes you can get more partial marks if they can find some correct components on the diagram. So there's a mark for resolving forces in most questions. So if you have shown that on the diagram correctly, and even if your working is wrong, sometimes you can get partial marks. So that's one reason to show this on in the exam as well. Okay. If the plane is rough, do we assume acceleration is zero? No, we never assume that. If the plane is rough, then if Q states limiting equilibrium, Sanya, you've mixed a lot of things together, as in, if it's limiting equilibrium, then the object is not moving in the first place. And then if it's not moving, then acceleration is of course zero. But if it is moving on a rough surface, then generally it will be some negative acceleration. Okay, it will not be zero. If there's only friction acting, it will be negative acceleration. Yes, Anna, you should definitely do that. You should do that. If you're continuing on an additional page, make sure that you write on the original question space as well that you're continuing on the additional page. And on the additional page, then write down the question number. It's okay if you forgot to do that in paper one. That's not getting checked anyway now. So most likely, I think that's what's happening, right? So it doesn't matter. So forget about B1 now. What should you do for revision? I've posted a 6-hour video on 2x that will become 3 hours, although I think that's going to be a bit too fast, but maybe 1.5x. Go through that. That will probably be the best revision for the exam. It'll cover all the concepts that you need to know about and the different types of questions that you'll get with that. If you are amongst the better performing students and you're aiming for an A star, you might find the difficult questions videos helpful as well. What do I mean? I just mean if they cancel paper one and have a retake, inshallah, then P1 is not going to be checked, right? As in, why would they bother checking that if it's not even going to be considered? And that's what I said. But I'm not speculating. I don't know what's going to happen. We'll have to wait for 7th, okay? I was just responding to that question, that if you ended up messing something up in paper one, it most likely does not matter now. Okay. Okay. In the inclined surface questions, do you consider the weight component acting down the plane as work done against friction? If object moves up the plane, no, you never do that. In work energy power questions, when you use work energy principle, remember driving force and resistance, they do not include weight. Weight is not considered as a driving force. Weight is also not considered as a resistive force. Okay, it's not considered. So it's not considered here, it's not considered here. Weight or any of its components. No, we don't consider them. Okay, we'll come to those questions. We'll come to those questions. I think the general questions are almost done now. Is this a session on all types of questions? It's not. It's a Q&A session where I'm just answering questions, some general questions in the beginning, and then we'll come to some specific questions after that. For all different types of questions, I've posted an M1 revision workshop. You can have a look at that. Can we always use work energy principle on inclined surfaces instead of constant acceleration equations? You can do that, but a lot of times when you know that acceleration is constant, it will be more efficient to do it using the constant acceleration formula. So work energy principle might make it slightly less efficient because they would give the information accordingly, that they would give information assuming that the candidates will use constant acceleration formula. So that will be the more efficient way of doing this. But if you want to do if you want to use work energy principle in those cases, that's okay. But it does not work the other way around. If there's a work energy power question and you can do that using work energy principle, a lot of times, in fact, most of the times, the constant acceleration formulas are not going to work unless you are sure that acceleration is constant. How do you know acceleration is constant? If all forces acting on an object are constant, then you say acceleration is constant. If that condition is not satisfied, then you cannot use constant acceleration formulas. So if it's not given in the question that acceleration is constant, and it's not one of those common cases like free fall or smooth inclined surface, how do you figure out if acceleration is constant or not? If all forces are constant, you say acceleration is constant. Now, if you're not sure that all forces acting on the object are constant, do not use constant acceleration formulas. Even if you get the correct answer, they will penalize you for that. Okay. So in work energy power questions, prefer work energy methods. Okay. Zen and SS equalizer, we'll come to that question. उस पे आते हैं अभी, इस पे भी आते हैं. Is working in columns allowed? We've talked about that multiple times before. Examiner generally discourages that you do that, but practically it's not possible to do everything without doing some of the working in columns. For example, when you have to have multiple cases, for example, this was one question. Yeah. So for example, this is a 2-mark question, and we have to do some working for that. There are different parts of the question. There's one part here, another part here, another part here. There are 3 parts of this journey. Now we have to do calculations for them. This is the space that they've given. Okay, this is the space that they've given. Now, if this is the space that is given, and we have to do all of this working, there's no way to do it without working in columns. Now they discourage it. The reason that they give for that is that they say sometimes the examiner cannot understand the order of your working, that what step you're doing after what step. So as long as you're very clear in your working, that the flow is clear, that what comes after each step. And you're not jumping around like this, that you do one step here, then another step here, and then you go here, and then you go here. That will be problematic if you do it something, if you do something like this. But if you're careful about that, and it's very clear the order in which you're showing your working, and you're sure that the examiner will understand the order of your steps, then it's okay. All right. Otherwise, you'll have to take a lot of additional sheets that will waste a lot of time as well. So yeah, you can do that. Acha. Acha, we'll get to specific questions now. We'll get to specific questions. Do we need to simplify quadratic equation by factorizing out common multiple? Depends on what you are trying to do. It's not necessary generally. Sure. Let's start with some specific questions now then. Do we need to write units in M1? It's not necessary, but make sure that you understand the units given in the question. Sometimes they give something in kilos, like kilojoule, kilowatt. Just be careful that you are using the correct unit. In the final answers that you give, it's not necessary to write units. Unless, again, sometimes they ask you to give your answer in kilowatts or kilojoules. That's the only case in which it will be a good idea to write down the unit. But as long as your final answer is correct, the value is correct, they will not deduct marks for that. Okay. If there's a ring on a circular track, where will the normal reaction force act? That's a good question. Let me show that to you. Okay, so can I actually find that question? I don't remember where exactly that would be, but let me just draw a circle myself
सर वो
here.
नवंबर 22 का 4-3 का क्वेश्चन 3
November 20,
नवंबर 22
22. Okay, November 22.
पेपर 4-3 का क्वेश्चन 3
Paper 4, 3%. Okay, so when you have a circle like this, actually, I'll probably need to copy this on the side. Look, when you have a circle like this and there's a ring here, in which direction does normal reaction act? Remember the rule that we've got for that? The standard rule that we've got for that? Reaction always acts perpendicular to the surface. Reaction always acts perpendicular to the surface. Now, what's the surface that the ring is in contact with? The surface is that of the circle. Now, what's the direction of the surface? It will be the same as the direction of the tangent at that point. Normal reaction has to be perpendicular to this tangent. Okay? If you were to draw a tangent to the circle at this point, normal reaction will have to be perpendicular to that. Now, if you draw perpendicular to this, you can say it's the normal at that point. Normal reaction, you've done normal in P1 differentiation as well, right? So it's basically that normal perpendicular to the circle at that point. And this line that we have drawn in which the normal reaction is going to act, this is actually going to, if you extend it, this is going to pass through the center of the circle, right? Because normal to a circle at any particular point, it always passes through the center of the circle. Why? Because tangent and radius are perpendicular, right? And tangent and normal are also perpendicular. So at that point, if you extend the normal, it will pass through the center of the circle. So it will be this direction. Now it could be either towards this side or this side. Both are possible. It could be towards the center or away from the center. Now, which one of the two is it going to be? It depends on the rest of the forces. So if the rest of the forces in this direction, in the downward direction, are greater, then normal reaction will act in this direction. If the other forces towards the center are greater, then normal reaction is going to act in this direction, because reaction is something that reacts to some other forces. So whichever of these two sides has greater forces, reaction is going to be opposite to that. Does that make sense? Right? Okay. If you use conservation of energy, remember the difference between those two formulas that we've got, M1 work energy principle. In the work energy principle formula, we have change in kinetic energy, change in potential energy. When we talk about change, change can be positive, change can also be negative. Both of them are possible. So in this case, change in kinetic energy could have a negative value as well. Change in potential energy could have a negative value as well. However, if you are using conservation of energy in some case, when do you use that? Only when there is no driving force and there's no resistance. When those two conditions are met, then we can use conservation of energy as well. In this case, we are using the actual values of kinetic energy and potential energy. We're not talking about change in this case. And energy is a scalar quantity, so it cannot be negative. So in this case, the height that you consider, that will also not be negative. In the change formulas, we had mg delta h, mg into change in height. So that change in height could be negative there as well. But when we have absolute value of potential energy, when you use conservation of energy, in this case, you only use positive values. So now those of you who get confused with this is a general method that works everywhere. Okay, this is a general method that will work in every single case. So even if you do not want to use that other method, that is okay. This will work everywhere. Okay, but the other method that does make some questions simpler. When there is conservation of energy, it is more efficient to use that other method. But still, this will also work. Okay, this will also work if you want to use that. Okay, is Lami's theorem necessary? It's not necessary. Uh, you can do everything without that as well. Lami's theorem is just an additional method which makes things more efficient in some questions and saves time. What are those questions? When these two conditions are met, there's equilibrium and you have exactly three forces. That will help you save time in some specific questions like this. And time is really precious in an M1 exam. So if you know how to do that, that's going to help. But otherwise as well, you can do everything by resolving forces. This is not part of your syllabus, so you're not required to know this. You're not required to know this. You can do everything without this as well. Okay. All right. Topical from 2020 to 2025 and yearlies from 2020 to 2023. The recent yearlies that you haven't done, or so if you've done topicals until 2025, that means you've covered the recent papers as well. Just make sure that you go through those recent questions again. That is important, but I think that should be good enough practice. Shami Sahib, if that's what your name is. Okay. I think we need to start getting to some specific questions then. Chale, let's start with some specific questions now. Let's start with specific questions. जी बताएं. November 22, paper 4-3, question number 3. Okay, that circle question as well. Yes, Usman, that's correct. That's correct. Okay, Chandra, let's have a look at some of these questions now. I will try to answer all the questions, inshallah, all questions, okay? All the questions that you guys are asking about, we will try to do them, inshallah. If not today, then definitely tomorrow, inshallah, but we will discuss all of them. Acha. So the questions that I already have solved, those of you on Zoom right now, you have access to them in the OneNote notebook that you have in the group description. You've got all of these solutions available there, and the videos corresponding to them available in the playlist that you have as well. Okay. So if you don't understand any specific question, you can go to the specific solved paper and you'll find that solution. If you still don't understand, you can watch the corresponding video as well for that. Achha. Now, November 22, paper 4.3, I'll start with this. November 22, paper 4.3, question number. Achha, that was only for asking about this. Okay, what I'll do is I'll just explain the solution to this question as well. Let me do this. Okay. So what did they give in this question? There's a ring of mass 4 kilograms that is threaded on a smooth circular rigid wire. Okay, so it's a smooth wire, there's no friction. It has center C. The wire is fixed in a vertical plane, the ring is kept at rest. At rest means it is in equilibrium by a light string connected to A. Okay, now where is the string? This is the point A. There is a string connected to that, and that is this. Okay, this is a string connected to that. Okay, now A is the highest point on the circle. The string makes an angle of 25 degrees to the vertical. You're given this angle here as well. Okay. Now they're saying find the tension in the string and the magnitude of the normal reaction of the wire on the ring. Now it's an equilibrium problem. All you have to do is represent all the forces, resolve components, resolve all the forces, and equate the opposite forces, right? That's all that you've got to do. Now, what are the forces that are acting in this case? What forces are acting in this case? Let's think about all of those forces. So at the ring, there will be tension towards the string. This is one force that is acting, tension. Away from the ring and towards the string, that will be one force, okay? There will be weight of the ring, weight acts vertically downwards. There is this 40 Newton weight because the mass was 4 kilograms. We've got weight as well. Okay. So tension and weight, these are two things that we have represented. What else do we have to think about ourselves? Friction. There's no friction in this case. It's a smooth surface and normal reaction. Now, what about normal reaction? Which direction does normal reaction act? We talked about that. It'll be perpendicular to the curve at that point. So that means it'll either be in this direction, use a different color. It'll either be in this direction or in this direction, right? These are two possible directions perpendicular to the circumference at that particular point. Now, which of these two directions is it going to be? How do you figure that out? We will have to first find the components of weight and tension. Find the components of weight and tension and see where they act. In fact, we have to find the value of tension. Are we given any information here? Tension, weight is acting in the downward direction. We have to figure out which of these is greater. Okay. Now, we can't actually figure that out in this case because tension is unknown. So it's not possible to figure out in which direction a reaction is going to act. In such cases, what you do is you can take one direction that may be possible and you just assume that this is R, for instance. Okay. It could be in the other direction as well. You could have taken in the other direction as well, depending on which force is greater. So, for example, if weight was greater, it could have acted in the other direction as well. You'll just start with one direction. Let's suppose we start with this. If at the end the value of r turns out to be positive, that means you've taken the correct direction. If it was not the correct direction, all that would happen would be you would end up getting a negative value for r. And that would tell you that the direction that you took in the beginning, that was wrong and it's actually acting in this direction. The negative sign will tell you that. Okay. So in case you cannot figure this out, in case of reaction, you can just start with one direction as the possible direction for r. So that's what I've done here. We've got these forces that I'm now going to highlight. There's tension acting in this direction. There is normal reaction acting in this direction. And there is a weight acting in the downward direction. These are the three forces that we've got. Now we've got to resolve these forces. How do we resolve these forces? I've got this question multiple times before as well. How do we know which directions to resolve forces in? Generally, when we have a surface involved, we resolve forces parallel to and perpendicular to the surface. So that means parallel to the surface and perpendicular to the surface. You could resolve in these directions if you want, and that's perfectly okay. That will work. If you want to resolve the forces in these two directions, you can do that. But since it's going to make things complicated because we only have reaction acting in this direction, generally, when we take the direction of the surface as the one that we resolve in, the reason for doing that is that most of the forces are already acting in those directions. We have reaction acting in this direction, maybe friction acting in this direction, another force acting in this direction. So we only have to resolve a couple of forces that may be left. In this case, however, it does not really benefit us a lot if we take these directions because only reaction is acting in that direction. If you want to do this, you can do it. That'll also be okay. An alternative could be that you could just resolve horizontally and vertically. That'll also be fine. So all that matters is the two directions that you resolve the forces in, they should be perpendicular to each other. So what I've done is I've resolved the forces in these two directions. Now, how do we resolve them? What I'll do is I'll actually get rid of these for now. So maybe it makes a bit more sense. We've got these forces T, R, and weight, that is 40. Now, if I resolve vertical and horizontal, what are going to be the components? Weight is already acting in the downward direction. Okay. What about tension? We know that this angle is 25 degrees. If this angle is 25 degrees, A is the highest point. That means this is a vertical line. This is also a vertical line. So we know that these are alternate angles. If that is 25, this is also 25, right? So we could say the component of T acting in the vertical direction, that will be T cos 25. And the component of T acting in the other direction, in this direction, that will be T sine 25. Okay. Then what about normal reaction? Now for this, we need to think about it again. This is 25 degrees. If we make an isosceles triangle like this is an isosceles triangle in which two sides are equal, right? These are two radii. So if this angle is 25, we know that the other angle here is also going to be 25. So these two angles are the same. They're both 25. And now we know this is 25, this is 25. What is the angle left here with the horizontal? This is 40 degrees. And if this is 40 degrees, it's a vertically opposite angle on the other side. This is also going to be 40 degrees. So what are the
सर आवाज नहीं आ रही आप
Okay, can you hear me now?
जी सर अब आ रही।
Okay, so when did I lose connection? As in, when did my audio stop? How long has it been? A few seconds only? Okay, all right. So once we know this angle is vertically opposite, this is also 40. We can resolve the forces. We have resolved the forces. This is r cos 40, adjacent angle. And on the other side, we have r sine 40. Now, when you have resolved the forces, after that, it's fairly straightforward. You just equate the opposite forces. Vertically, we have t sine t cos for 25 acting in the upwards direction, and these two forces acting in the downward direction. Horizontally, we have t sine 25 acting to the right, r cos 40 acting to the left. Equate the opposite forces, solve those equations, and that will give you the result. Okay, so once you've resolved those forces, the rest is straightforward. Now, this is one way of doing this. You could choose to resolve parallel to and perpendicular to the circle at that point as well. That is also fine. You will get the correct result using that as well. Okay. Aisha, the problem is, I'm not sure if we can say whether the tension component acting in this direction is going to be greater or the weight component acting in this direction is going to be greater. Does that say in the question anything like that? It is kept at rest by a light string connected to A. It is kept at rest. So if weight component was greater, yeah, so using the context of the question, you could say Uh, the question says the ring is kept at rest by the string. That means the string is kind of pulling the ring in the upwards direction. Because of that, the reaction will be in this direction. But even if you're not able to figure that out, it's okay. There's nothing to worry about. You just start with one direction. If it was actually the other direction, you will end up getting a negative answer, and that's also okay. There's no problem with that. Okay. Our angle in the marking scheme is 50. They would have used the other angle. They might have used this angle 50. So they would say this component is r cos 50 and the other is r sine 50. That's the same thing, right? Sine 50 and cos 40, they're both the same. Cos 50 and sine 40, they're also the same. So it doesn't matter. Okay. Acha. Let's do another one. Let's do another one. Okay, so there was one question that was repeatedly being asked here. Since we've done that already. So some of these questions, since I've done live with you guys already, what I'll do is I'll focus on the older questions first. Okay, people on Zoom, do you have any specific questions? You guys have any specific questions after this? Do you guys have any specific questions? No? Okay, that's all right then. What you will do is you will make use of these resources that you've got. Okay, make use of them. Whenever you get stuck at a question, you will most likely find the solution for that in the notes. The last 5, 6 years, all the difficult questions, they are there, both in notes form and also in the video form in the playlist that you've got. Okay. Uh, there was one more thing. Yeah. So I am posting some videos on difficult questions from recent papers. So I assume that many of you were not able to do all variants from the last 5, 6 years. So just like for other papers, I have a playlist for difficult questions from recent years. You'll find a lot of questions there already. I'll be adding more to that overnight, inshallah, or tomorrow. But look at the videos that are already there because they cover the difficult questions from 2020 to 2024, roughly. Okay, I'll add more to that, but the rest of them you've already done with me live. So the older papers, from those older papers, the more difficult questions you will find in those difficult questions videos. Now that's only for those of you who are expecting an A or an A star, inshallah. If you're struggling, then those videos are not for you. You should focus on revision. That's going to be more important for you. Okay. So difficult questions are only for those people who are aiming for who are expecting an A or an A star. That's what they're looking at based on their performance until now. Okay. Otherwise, you will benefit more from revision and not just difficult questions. Okay. Acha, March 23. Usman, you can be a bit more clear than that. March 2023, paper 4-2. Is that what you mean? March
जी
20,
सर।
paper 4-2. Okay, all right. Okay, we were looking at that paper, Abhi. Question number 5 of this, okay. How to resolve forces in this case? What's the problem with this?
सर इसका जो पार्ट बी है ना उसमें एक हॉरिजॉन्टल फोर्स भी लग रही है, वो समझ नहीं आ रहा था मुझे किस तरह रिजॉल्व करना।
Acha, so this is a very important point. In some cases, you'll find in past papers, you might not have come across a question like this until now because there are not many of them. When they have a string-like thing, as in something that is used to connect two particles or support one particle, and that thing is rigid. In this case, we have two sloping struts. Now, this is something rigid. There's something rigid, like when you have two objects connected, for example, two vehicles connected, for example, you have a car that's towing a trailer. In that case as well, sometimes you have a rigid tow bar. It could happen in that case as well. What can happen? That when you have a rigid thing connecting two objects, you can end up with a negative value for tension sometimes. You can end up with a negative value for tension sometimes. Now, why would that happen? The reason for this happening is that we always take the direction of tension as being away from the point of reference. So whichever point we are talking about, for example, if we're talking about this block, on this block, the tension in those struts is going to be away from that point. That's what our assumption would be, that it is going to act away from that point of reference if you're talking about that block there. However, if it's a rigid thing, if it's a rigid thing, if it's a string, this will be the direction every single time, away from that point and towards the string. But if it's a rigid object like this, sometimes what can happen is that the actual direction might be opposite to what you are taking. Now, how would you know? You would not know. It's not required by your syllabus. You will just start with the standard assumption. And that is that the tensions you will take will be away from the point of reference. You will start with that assumption. But then when you actually solve that question using that assumption, sometimes what can happen is that you would end up with a negative value for tension. Negative value for tension. So in this case, we're getting negative square root of 2 times f, for instance. That is okay. You will just use it as it is in your calculation. The reason it is happening is the actual direction of this is in this direction. That is why it's turning out to be negative. You are not going to change anything in your working. You will do everything the same way as before. Just remember, if you end up with a negative sign and it's a rigid thing, this is possible. It can happen sometimes, and it is going to be correct. As long as your working is correct, this is fine. Now, in this question, they did not ask us for the magnitude of the force in the strut AD. So that's basically tension. They gave you that value, right? But if they ask you for the magnitude of this tension, then in the final result, you will just, when you write down the magnitude means the numerical value, ignoring the sign. In the final result, you would just write down this number, ignoring the negative. But apart from that, your working is going to be the same way as you've been doing before. Okay. Now that was just a side point that I remembered in this. Now, what exactly is your question, Usman? So we have this horizontal force F applied to the log in the direction parallel to AB. Okay, so we've got this force acting F to the right side. Find the value of F for which the force in the strut AD is equal to 0. So we have this force acting to the right, which is F. What are the other forces? Tension acting in this direction, tension acting in this direction. We've got weight acting downwards. You would just resolve it the normal way. What's the confusion here? Is the negative sign the confusion? You understand that now? Don't worry about that. You will work through the problem the standard way. If it turns out to be negative, so be it. That's correct. There's no problem with that. Okay? ठीक है. Okay. चले. People on Zoom, do you have any specific questions? Because otherwise, I'll answer other people as well then, because they have questions from recent papers, which we have already done live. So I'll just answer those now then. Okay, so if anyone wants to leave, you're free to leave then. I'll see you again tomorrow, inshallah. If you guys have any questions, if you think you can make better use of this time, and you don't have any specific questions, maybe just spend that time on revision. Okay. Allah Hafiz to everyone who's leaving. I'll see you again tomorrow, inshallah, if you have any questions. All the best with your exams, inshallah. Acha. Uh, Let me answer these questions now. Some of these specific questions from YouTube. How to determine the normal reaction force when our ring is on a rough horizontal road and force acts on angle above the horizontal? That's a standard kind of question. Explain the question type with two boxes on top of each other. May, June 2024, question number 7. May, June 24, question number 7. Let's look at that. The two boxes question, if you look at the M1 crash course playlist, एक तो आप लोग अपने नाम अजीब रखते हैं इतने कि वो बोलते हुए भी बंदा सोचता है कि बोलना चाहिए कि नहीं बोलना चाहिए. जो भी पूछा है बॉक्सेस वाला जो है, if you want to look at that solution, see M1 crash course playlist, उसके अंदर देखें the forces and equilibrium topic, उसमें जो past paper questions वाली वीडियोस है लास्ट एक दो, उसके अंदर you'll find the solution for that. M1 crash course. Let me just show that to you quickly. अच्छा, this is the M1 crash course. If you go there, आपको यहाँ पर फोर्सेस एंड इक्विलिब्रियम में ये लास्ट एक दो वीडियोस में आपको वो मिल जाएगा क्वेश्चन। ठीक है, फोर्स एंड इक्विलिब्रियम की लास्ट दो वीडियोस में मोस्ट लाइकली आपको वो बॉक्सेस वाला क्वेश्चन सॉल्व मिल जाएगा। ओके, अच्छा। May June 2023 question number 2, why do we not consider normal reaction? May June 2023 paper 4 2 question number 2. अच्छा, let me go to that. I'll come to the other questions as well जो मैंने पीछे ऊपर chat में miss हो गया। I'll come to them. अच्छा, मैं इस पे आ रहा हूँ अभी। June 23 paper 4 2. Actually, that's actually a very good question. Let me go back to that. Uh, do you remember which paper that was? I think it's there in the chat. March 2023. Okay. Okay, so there's a question. It's a rigid strut, right? So why are we not considering reaction in this case? Why are we not considering reaction in this case? It'll be one of the two things. If the force is applying in this direction, if the block is applying a force on the struts, then that will be tension in this direction. But if it is in the other direction, in this direction, like it is in this case, we are getting a negative value of tension. We're calling it tension, but actually it's not tension, it's something else. That's why they're just saying magnitude of the force in the strut 80. Now they're not specifying what that force is. Sometimes it's called thrust. In this case, it could be normal reaction as well. So the thing, what is happening in this case is, since the actual force is acting in this direction, you could actually think of that as normal reaction. That there's a normal reaction that is being applied by the strut on the block in this direction. That's perpendicular to that strut, right? So the reason it's negative is that that force is actually normal reaction. But we will just consider one of them. It'll either be normal reaction or tension. If tension turns out to be negative, that means it was actually normal reaction in that direction. So you could consider it that way as well. So it is being accounted for there when we consider tension there, okay? All right. I think that answers your question, but probably confuses other people. So I'll just ask everyone else to ignore that. So that was May, June, not May, June 23, October, November 23. Okay. October, November 23, paper 4 2. November 23, paper 4 2. Let me go to that. November 23, paper 4 2. TABB6512. द टिप इज कि जाके पढ़ लें, ये ए लेवल स्ट्रीम्स में टाइम वेस्ट नहीं करें। दैट्स माय टिप फॉर योर यूनिवर्सिटी एग्जाम। वी नॉट डूइंग डिफरेंशियल इक्वेशंस हियर। November 23 paper 4 2. November 23 paper 4 2, question number 2. Okay, Achha, let me show you this question. We have this diagram that shows a smooth ring R. Its mass is m kilograms. It's threaded on a light and extensible string. A force of magnitude 2 Newton acts on R. You can see that in the diagram. This is 2 Newton force acting to the right side. A and B are points on the vertical wall. You can see that as well. This is a vertical wall. A and B are points on that wall. Okay, A and B are points on that vertical wall. The part AR of the string makes an angle 30 degrees with the vertical wall. वो भी आपको नजर आ रहा है डायग्राम के ऊपर. BR makes an angle of 40 degrees. वो भी नजर आ रहा है. Find the tension and the value of M. Now the ring is in equilibrium. Equilibrium means the opposite forces are all going to be equal to each other. So all we have to do is represent all the forces and equate all the opposite forces. Okay? Represent all the forces and equate all the opposite forces. Okay? Umar, I'll come to that. I'll come to that, Abhi. अब कौन सी forces act कर रही हैं? There is tension. So on the ring, there will be tension in this direction, and there will be tension in this direction, away from the ring and towards the string. So one part of the string is above, and the other part of the string is in this direction. Now, are the tensions going to be equal? Yes, it's a ring. The string is free to slide through the ring. The tensions on both sides, they are going to be equal in this case. So it's equal tensions. The question also kind of tells you that because they're using a singular here, right? Find the tension. So that means the tensions are equal. Okay, what else is acting on the ring? There is 2 Newton force acting to the right. There is weight. M kilograms is the mass, so weight is going to be 10 times M. And that's it. You resolve all the forces, equate the opposite forces. There's a force acting to the right, 2 Newton. Resolve this tension, T cos 30, T sin 30. Resolve the other tension. For this, we'll have T cos 40 in this direction, T sin 40 in this direction. Equate the opposite forces after that. The green forces, they must be equal, and the yellow forces, they must be equal. Left equals right, up equals down, and that will give us the result, right? ठीक है. अच्छा, चलें. Let me look at this question now. November 4/3, 2022. November 22, paper 4/3. Question number 4, let's do one of these, and then we will do another. उसके बाद हम इसमें वापस आ जाते हैं. Question number 4 and 5. Okay. Have I solved that anywhere before? Just to make it quicker. Yeah, okay. Let's think about it. We have particle P that travels in the positive direction along a straight horizontal line. Acceleration is constant. P travels a distance of 52 meters during the second of its motion. Second, what does that mean? Second means from time equals 1 to time equals 2. So time equals 1 से लेकर 2 तक, we are given the value for displacement, that is 52 meters. Now, what's the time duration? Time duration is 1 second, right? Time duration is 1 second. पिछले क्वेश्चन में रिएक्शन क्यों नहीं लिया? रिएक्शन किसी सरफेस पे लेते हैं ना, कोई सरफेस तो नहीं था वहां पे, स्ट्रिंग थी वो तो सिर्फ. रिएक्शन तो कोई सरफेस इन्वॉल्व हो तब लेते हैं. Why would we have reaction in that case? In the previous question. Acha. In the second, it travels a distance of 52 meters. And in the fourth second, it travels a distance of 64 meters. What that tells us is from t equals 3 to t equals 4, the displacement is 64. And from t equals 1 to t equals 2, the displacement is 52 meters. Now, let's break the journey down like this. 0 to 1, we don't know anything about that part, just that the acceleration is constant. From time equals 1 to time equals 2, we know that the displacement value is 52. And then from time equals 3 to time equals 4, we know the displacement value is 64. Now, what information do we have about both parts of the journey? So what's common between both parts? Time taken is 1 second, right, for both of them? Time taken is 1 second. Acceleration is common in both of them. Its acceleration is constant. So what if we call acceleration A? We're calling acceleration A in this case. If we call that A, we could say the displacement value at time equals 2 and the displacement value at time equals 1 from the initial point. This is one way of doing this. Displacement at time equals 2 and displacement at time equals 1. What's their difference going to be? Their difference is going to be 52 meters. So what we can do is, one idea could be, we find the displacement up to 2 seconds, ut plus half at squared. Let's call this speed u, initial speed, and that becomes u into 2. That's the time taken from the starting point to time equals 2, plus half a into t squared. a into 2 squared. Subtract from that the displacement from 0 to 1. Again, the initial velocity is going to be the same in this case as well. That's why we are doing this, so that we don't have too many unknowns. U is going to be common between both the parts of the journey, right? So in this case as well, initial velocity is U, time taken is 1 in this case. We are given that this difference should be equal to 52 meters. So we equate this difference to 52. That gives us one equation. We can make another equation now. From time 3 to time equal to 4, that will give us another equation, right? Okay. Allah Aisha, I'll do that. Please just send a message in the group as well. Okay. Send a message in the group. I'll respond to that. Acha, time equals 3 to time equals 4. You do the same thing in that part as well. You find the displacement at time equals 4. Subtract from that the displacement at time equals 3. Equate that to 64. And that gives you another equation. You've got these two equations. Solve them simultaneously. You're looking for both of them, initial speed and acceleration. Solve them simultaneously, you'll get those values. Does that make sense? No, that's not what it means. And the displacement from t equals 2 to 4 is not 64. They said in the fourth second. Fourth second means from t equals 3 to t equals 4. Okay? That's what it means. Okay, you could also use limits in this case. That will also work. So make a displacement function, input limits 2 to 1. You'll get the same thing from that as well when you input limits. But you could use that idea as well. The first part was the problem, right? The second part, I think, should be straightforward. After that, distance traveled during the first 10 seconds after motion. That is straightforward, right? Just input values in that formula. So that's not complicated. Uh, November 22, paper 4-3. That's what I did, right? Okay. So November 25. I'll come back to that question again, question number 5 next. Let me answer somebody else's question as well first. Saad, I've answered one of your questions as well. I'll look at another one first. May June 24, paper 4-2, question 6. I'll come back to those questions. I will answer those as well. Just be patient. Just be patient. June 24, paper 4-2. June 24, paper 4-2. First the number. 6. Okay. Question number 6 from that. Okay, that's a pretty long one. What I'll do is I'll guide you to a video that I have posted on this. Have I posted this already or not? June 24, paper 4-2. I have done it until, yeah. Let me find that for you. Let me find that for you quickly. I'll share that. Math for difficult questions. Okay, this is a playlist. In this playlist, you'll find this video. Okay, search for this video. Search for this video. You'll find that question solved here. That's going to take a lot of time to explain. It's very complicated. So you'll find a detailed solution here. Maybe you can watch that in 2x quickly. I'll tell you where it is. Yeah, it's right here. At around the 1 hour mark. 55 minutes. 55 minutes. 55-minute mark in this video. 55-minute mark in this video. You will find that. Okay. How do I share the link for this there? You have to search for turn on. Maybe in the history it might be showing. Okay, so I'm posting this link in the chat. I'm posting this link in the chat. You'll find that question at the 55-minute mark in this video. Okay. So the solution to this question number 6 from this paper, June 24, paper 4.2. I've posted this link, 55-minute mark in that video. You can save that maybe to see overnight. 55-minute mark, you'll find that this question solved. Okay. All right. Acha, May June 2019, that will be a question that I've not solved. So what I'll do is I'll do that right now. Okay, so let me actually answer the ones that I have solved because they will be quicker, slightly quicker. Solved November 25, paper 4.2, question number 4. November 25, paper 4.2, question number 4. Acha, I'll be posting videos on difficult questions from recent papers. Uh, So that will include the 2025 questions as well now. I'll post one more at night, inshallah, and maybe more tomorrow morning, inshallah. So you'll probably find most of these questions in those videos as well, explained in detail. Let me quickly go through this. A particle P of mass of 0.1 kilograms is projected vertically upwards with speed 30 meters per second from horizontal ground. At the same instant, a second particle of mass 0.4 kilograms is projected vertically with speed 10 meters per second from a height of 15 meters above the ground. Acha, this height is 15 meters. I'll answer that 2019 question next, okay? 2019 question next, because I think it will be more efficient if I just post these videos. मैं videos post कर दूँ and then I can, just refer you to those videos. जो 2019 वाला क्वेश्चन है वो मैंने अभी सॉल्व नहीं किया होगा तो वो मैं अभी करता हूँ फिर अच्छा height above the ground at which the particles P and Q collide. Okay, so what are we given? P is projected from ground. Q is projected from a point that is 15 meters above the ground. So their points of projection are different. Their points of projection are different. Okay. Now, this is projected at a speed of 30 and this is projected at a speed of 10 meters per second. What information do we have about both of them? U is 30 for P, A is minus 10, time is T. For Q, initial velocity is 10, acceleration negative 10. If you're considering upwards positive, acceleration will be negative 10, right? If upwards is positive, acceleration, since gravity acts in the downward direction, acceleration will be negative. So these are the pieces of information that we've got for both the particles. Time is going to be the same for both of them. Why? Because they're both projected at the same instant. Okay? They're both projected at the same instant. So the time taken is going to be the same. Now, we also have some information about displacement. What information do we have about displacement? Displacement of Q until the collision happens. Let's say the collision happens at this point. The displacement of Q until that point, if we call that SQ, and the displacement of P until that point, let's call that SP. SP is this total distance that is going to equal 15 plus SQ. So we can make an equation from that like this. We make this equation, we solve this equation, and that will give us the value for T. That's the time instant when this collision happens. That's the time instant when this collision happens. Okay, so we find that time instant. Once we have figured that out, then we just have to find the displacement of P from the ground at that point, and that will give us the height above the ground at which collision happens. So we can find SP after that, UT plus half AT squared, input values in that, and that gives you the result. Okay, you can have a look at the solution. Let me know if there's a specific question on this. Okay, that's part A of this. Part B says when P and Q collide, they coalesce. Find the speed of the combined particle at the instant that it reaches the ground. Okay, now this is the tricky part, right? So what happens is when they collide here, we know the height at which that this collision happens. This is the height at which the collision happens. Okay. Now, after collision, what's happening is they are coalescing. First of all, we need to find the speed of the combined particle at the instant it reaches the ground. In fact, that's the final thing that we want at the end. Now, we'll have to break it down. We'll have to break it down. First of all, there's a collision happening. So we have to apply conservation of momentum at that point, right? When collision is happening. For that, we need the speeds of both the particles Vp and Vq just before they collide. So at the point of collision, we want their speeds. So basically the final speeds in their journey from top to that, from the bottom to that point. What's the final speed for both of them? We have found displacement time as well. We've got the time value as well. We can use v equals u plus at, and that will give us the velocities for both the particles. So what we do first is we find their velocities. These are the velocities at the point of collision. Velocity of p and the velocity of q just when they collide. Okay. All right. Now we know what happens before collision. We know their velocities before collision. They're both positive, so we can say they're both moving in the upwards direction. They coalesce, so their masses get added, it becomes 0.5 kilograms, and we have the velocity of the combined particle. We call that combined particle PQ. We can use conservation of momentum, find the velocity of that combined particle right after collision. Okay. Now, this is also turning out to be a positive value. What does that mean? If it's a positive value, we were considering upwards positive when we applied conservation of momentum. So right after collision, this particle is going to start moving in the upwards direction. And then it can't keep going on in the upwards direction forever. At some point, it's going to start coming down, right? So its journey is going to look like this after collision. Now, what do we know about the particle after collision? We know its initial velocity, that is 6.5. It will be in free fall after this, right? If we consider upwards direction positive, what about acceleration? Acceleration is going to be negative 10. So we have the initial velocity after collision. We've got the value for acceleration. Is there anything else that we know? At the point of collision, we know the particle was at a height of 19.6875 from the ground. What is the displacement going to be? If we're considering upwards direction positive, then the displacement is going to be negative of that number. So that exact value was negative, was 315 over 16. Since in this case, the particle initially moved in the upwards direction and then started going in the downward direction. When we have two-way motion, generally what we do is we take upwards positive. Now, if we take upwards positive, we know the initial velocity of the particle is 6.5. We found that from conservation of momentum. Acceleration is negative 10. That's free fall. We're considering upwards positive. Gravity acts downwards, so acceleration is negative 10. What about displacement? The starting point is this. End point is below that. We are considering upwards positive. So the particle is eventually going down there. So displacement is going to be negative 315 over 16. Input values, nv square equals u square plus 2as, and that will give you the value for v. That's what we were looking for. Is that all right? Makes sense, okay? November 25 paper 4 to question number 4 and question number 5. Keeping a direction positive or negative. For conservation of momentum, you keep the same direction positive for all the object. For kinematics, this is the rule that we use for choosing positive direction. First of all, for any object, you need to keep a single direction positive throughout the journey. For every object, keep one direction positive throughout the journey. Do not change that in the middle. But how do we decide the positive direction? If it's a one-way motion, for example, the particle is going only to the right, we consider that direction positive. If the particle is only going towards left, we consider that direction positive. If it's only moving upwards, we take that positive. If it's only moving downwards, we take that positive. Okay. If it's two-way motion, that means the particle is going upwards and then coming downwards, or going right and then going left, or going left and then going right. In such cases, we consider right side positive when it's horizontal motion, upwards positive when it is vertical motion. Okay, all right. Acha. Ramna, let me come to that as well. I'm getting some calls here as well. Acha. What I'll do is, apart from that 2019 question, I will be posting uh, all of those questions that you are finding difficult in some videos. I'm going to show you the solutions for all of them right now. Okay, I'm going to show you the solutions for all of them. Take a snapshot of them. Take a snapshot of them. Try to understand. I'll be posting the videos that will contain those questions then. You can have a look at that. Otherwise, I'll solve them tomorrow, inshallah. Okay. Tomorrow I'll continue until late night whenever the questions end. But let me show you the solutions for that. 2019 question that I won't have right now, so I'll solve that. For the other ones, since the number has increased a lot now, let me show you the solutions for them. Let me show you the solutions for them. Take a snapshot and then let me quickly show them to you. Let me show them to you. November 24, paper 42. November 24, paper 42. Question number 5. Acha, I'm just going to show you the solution for this. You take a snapshot, take pictures, and then I explain the part that might be what you're confused about. Speed of each particle before they collide. This is basic kinematics, but after the collision happens, then they want you to find the speed of p at the instant that it reaches the ground. Now, how do we think about this? You would have to find the point of collision for this. That's going to be the confusion that you most likely have. The point at which the collision happened. How would you find that point? The point of collision. The particle P, the particle P, how much did particle P go in the upwards direction if we try to find that? SP, the displacement of P, input values in that, you end up with a negative value for that. Displacement of P, displacement turns out to be negative 0.25. When it turns out to be negative, what that means is the starting point of P, since the displacement is negative and we consider it upwards positive, if the displacement is negative, the collision happened below the point where P was projected from. Collision happened below the point that P was projected from. Okay. Now, what that means is, since the displacement before collision for P was negative 0.25, it was initially at a height of 1 meter. It was initially at a height of 1 meter. The collision point was 0.75 meters above the ground. The point of collision was 0.75 meters above the ground. Now, if that's 0.75 meters above the ground, the displacement value that you would take at the end would be 0.75. Now, in this case, I took downwards positive for the last part of the journey. That's why this displacement is negative, because it's only moving in the downward direction. The object after that is single direction motion after the point, after collision. It's only moving downwards. The displacement in that part is 0.75. Okay, I'll show you this working as well. If you want to take a snapshot of this, you can do that. Okay, does that answer your question? Acha, since the exam is closed, we should focus on 4.2. It doesn't make any difference. All variants have the same syllabus. Acha, November 22, paper 4.3. Acha, what I'll do is I'll come back in a few minutes. I'm getting repeated calls, so then maybe I can stay a bit longer after that as well. I'll be back in about 5 to 7 minutes, inshallah. Okay, we'll have a break. Uh, Let me write that down here. When I come back, I'll try to answer most of the other questions as well. So let's say we resume in about 10 minutes. We resume around 11:35. Okay, I'm getting repeated calls. There's somebody here to visit. I'll be back in about 10 minutes, inshallah. Okay. And then I answer the other questions as well. Okay. Acha, those of you asking about the 2024 and 2025 difficult questions, I would recommend that you have a look at that video link that I posted. You'll find most of the basically all the difficult questions from 2024 and 2025 solved in that. Okay. I'll be back in about 10 minutes, inshallah. Okay. Then I'll probably be able to stay a bit longer. Okay, everyone, let's resume. I'm sorry for the delay. Let me share my screen as well. Okay, you guys can see my screen again, right? Can you guys see my screen again? Can somebody please confirm? Yeah, March 26 paper is actually quite easy. That is fairly straightforward. Okay, I'm sorry for the delay. बाहर मौसम देखकर वापस आने का दिल नहीं कर रहा था मेरा अभी, but I had to be back. चलिए. I'm going to start with this 2019 question first. उसके बाद फिर I'll show you the solutions for the rest of them as well. Because उनमें से फिर कोई रह भी जाएगा तो they will be covered in the videos that I'll be posting. May June 2019 paper 4-2. May June 2019 paper 4-2. Okay, let me find that. Share here. Okay, all right. May June 2019 paper 4-2 question number. The last question from this. Okay, last question from this. ये देखते हैं. उसके बाद I'll show you the rest of them as well. Most of them I have them solved, so I will share how to do them with you quickly then, inshallah. Last one from this. Okay, that's one. That's the one. Let me take pictures of this. Okay, this is May June 2019, paper 4-2. Question number 7 from this. Okay, let's look at this quickly. It says find the greatest distance between P and Q for a time between 0 and 5. That's the one that you're asking about. But we will need the previous parts for that, right? Acha, so we are given particles. Yeah, I'll show the solutions for the rest of them as well. Let's just do this one question. उसके बाद I'll come back to the other ones, okay? अच्छा, चलें, let's start with this. Particles P and Q, they leave a fixed point A at the same time and travel and travel in the same straight line. The velocity of p after t seconds is given by this. The velocity of q after t seconds is given by this. Sketch in the same axes velocity time graphs for p and q for time between 0 and 5. Okay, let's do that sketch. This is velocity. This is time. We want to find velocity. We want to draw velocity time graphs. Time is going from 0 to 5 seconds. Okay. Now, this is a quadratic function and the other one is a linear function. Okay, for the linear function, it's going to be straightforward. We can just take 2 points when time is equal to 0 in this first function. What's the velocity? Velocity is 10. For q, let me write that down here. For q, the velocity function is 10 minus 2t. It's a linear function. We just need 2 points for this. T equals 0, v equals 10. That's 1 point. So it's going to start from from v equals 10. Let's mark this point as 10 because this is not going to go much big as well. So this should be okay. 0 and 10. That's 1 point that we've got. Take another point. You can take time equal to 5. When you put time equal to 5, you get velocity equal to 0. So at time 5, the velocity is going to be equal to 0. This is the function that we've got. This is the graph that we've got for Q. Okay, that's one thing that we were looking for. Now, the next thing that they want us to draw is 16 to t minus 3. That's a quadratic function. This is a quadratic function. V equal to 6t into t minus 3. That's a quadratic function. How do you sketch quadratic functions? You need the intercepts and the turning point. Do we have the intercepts? If we put v equal to 0 in this, v is on the y-axis, right? So when we put y equal to 0, we get the x-intercepts. One intercept would be t equal to 0 and another would be t equal to 3. So the intercepts are going to be at time 0 and time 3. Okay, that's what the intercepts are going to be. Then what about the shape of the graph? What's the shape of the graph going to be? The square term has a positive coefficient. The square term has a positive coefficient, so it's going to be a U-shaped curve. Okay. The intercepts are at the point 0 and 3, at the points 0 and 3. So we've got 3 here somewhere, let's say. Now, since the velocity is going to go to the negative side as well now, let's figure out what the minimum point is going to be. How do you figure out the minimum point? Minimum point is going to be exactly in the middle, right? Exactly in the middle at t equal to 1.5. The turning point of a function that is always, turning point of a function is always exactly in the middle of a quadratic function is exactly in the middle of the intercepts. So the graph is going to look something like this. You can find the value of t at this point as well, while value of v at this point as well. When time is 1.5, what's the value of velocity that we get? Let's just put that on our calculator. 6 into 1.5 into 1.5 minus 3. And that gives us negative 13.5. So, okay, so it's going way down there. So what I'll do, I'll have to do then is I'll have to take this graph slightly up. You'll always do this with a pencil. So in case you need to edit something, you can do that. Since the graph is going way down there, what I'll do is I'll have some negative part here as well. This is negative 13.5. So when time is equal to 1.5, velocity is becoming negative 13.5 for this. So the graph is going to go like this. For this quadratic function, it will go down like this, and then it's going to come up like this, and it'll keep going up and up like this until that point 5. Okay, what I'll do is I'll just bring 5 a bit to this side so that it becomes easier to show that point. This is roughly what it's going to look like. Okay, you label them. This is point. This is for the particle P. These are the two graphs that we get. Acha. Now they're saying Verify that P and Q meet after 5 seconds. Verify that P and Q meet after 5 seconds. Now, how do you figure this out? If they meet after 5 seconds, what that means is their displacement from the initial point, that must be the same. Okay. Now, what's the displacement of Q after 5 seconds? Let's figure that out. Displacement after 5 seconds for Q. You could do it using the area of the triangle. You've got the triangle now, so that will be fairly straightforward if you use the triangle. You can also integrate the function, input limits in that. That's also okay. Both of them would work. So for P, or for Q, in fact, what's the displacement after 5 seconds? Half into base into height. Base of the triangle is 5, height is 10. So we can use half into 5 into 10, and that is 25 meters. That's the displacement after 5 seconds for Q. What about P? P is a curve. We cannot find it directly using area formula for a standard shape. We'll have to do integration for that, right? Integration, use that to find the area between the graph and the x-axis. Let's figure that out. Now, notice one thing. The object is changing direction. The object is changing direction as well. It's changing direction at the point 3. So until from 0 to 3, from 0 to 3, this particle P is going in the negative direction. At time 3, it starts going in the positive direction. If they had asked us to find the distance traveled by P, we would have been required to break the journey at this point. We would find the displacement from 0 to 3 separately and then 3 to 5 separately. But in this case, we just want to figure out displacement, right? Because we want to show that the particles meet after 5 seconds. So we just care about the position of the other particle after 5 seconds. We don't care about the distance traveled in the middle. That's irrelevant. So what we do for that is we can directly integrate the function, the velocity function. What was the velocity function? Let me write that down here first. Velocity function was 6t squared minus 18t. What we can do is we can integrate it 6t cubed divided by 3 minus 18t squared divided by 2. Input limits from 0 to 5 directly, and that will give you the result. You can see what that is. You need to show the steps in which you input the limits. 6 and 3 get cancelled to give us 2, and that gives us 2t cubed minus 9t squared. And we cancel these two. Input limits from 0 to 5, input 5 in this, and that gives you 2 into 5 cube minus 9 into 5 squared. Subtract from this the case when you put t equal to 0, and that will be 0. Input this on your calculator. It should turn out to be 25 as well. 2 into 5 cube minus 9 into 5 squared, which is 25, and that gives us 25 meters. Since the displacement of Q and the displacement of P, they are both equal at t equals 5, that means they meet when time is equal to 5. Is that all right? They meet at this point. Make sense? Any issues with this? Any problems, anyone? Acha, now, who was that up there? मैंने पूछा था, what was the question? The problem was, you said, for greatest distance. Can somebody find what the problem in this question was? In the greatest distance, why are we? Yeah, so in the last part, what was the confusion? Let's do the last part now. Okay, now they're saying find the greatest distance between P and Q from t equals 0 to 5. Okay, so between 0 and 5, find the greatest distance between those two objects. Okay, now how do you find the greatest distance between those two objects? When will the distance be the greatest? Now, you see, P is moving in the positive direction, Q is moving in the negative direction. Now, P's displacement keeps increasing in one direction, Q's displacement until t equals 3 keeps increasing in the other direction. We want to find the maximum value of the displacement. Okay. Now, it's not clear from the graph at what point the displacement is going to be maximum because this is a velocity time graph, remember? Velocity on the vertical axis. So from the graph, it's not clear. We have to think about the areas under the graph, right? When the difference between the displacements is going to be the maximum. That is what is going to give us the maximum distance, right? Now, how can we figure that out? What we can do is we can find the displacement functions for both of them. We have the velocity function. A velocity function for one of them is 10 minus 2t. For the other one, the velocity function is 6t into t minus 3. Okay, so this is for Q and this is for P. Q is moving in the positive direction, P is moving in the negative direction. When is the difference going to be the maximum? Let's find the displacement functions and see what they turn out to be. Displacement function for Q, that will be 10t minus 2t squared over 2 plus c. We'll have to have a plus c here, right? Because we are looking for the displacement function. What about the displacement function for P? What would that be? That will be 6t squared minus 18t. In fact, that's the velocity function. We simplify this. That gives us 6t squared minus 18t. The displacement function is going to be 6t cubed divided by 3 minus 18t squared divided by 2 plus c. Now, these c's are, of course, different, not necessarily the same. Now, can we find the value for c? They are both leaving a fixed point A at the same time, and the displacement is being measured from that point. So initially we could say the displacement is 0. So at time 0, the displacement is 0, and that will give us the value of c to be 0. In both of these cases, since we know initially the displacement is 0, the value of c turns out to be 0. Now, you're not always going to assume that displacement, that the value for c is 0. You have to check that by inputting values. In this case, it's kind of obvious that it is going to be 0 because initial displacement was 0. Now, the displacement function that we end up getting from this, they are 10t minus t squared. And for P, this is 2t cubed minus 9t squared. Now, we want the distance between those two particles to be maximum. Now, what's the distance between those two particles? We know that Q was moving in the positive direction, right? P was moving in the negative direction initially. So we can subtract from SQ, SP, see what we get from that. 10t minus t squared, subtract from this 2t cube minus 9t squared. That will give you the distance between the two particles. Let's simplify this. And that gives you 10t minus t squared minus 2t cube plus 9t squared. I'm just thinking we could actually just do it directly from here as well in a way. Yeah, there was no need to integrate actually. We could do it directly. Yeah, but anyway, so I'll tell you what I'm thinking later, but let's just continue with this. So we have found the distance between the two particles. This is this. Now, what we want to do is we want to find the greatest distance between the two particles. When is the distance going to be the greatest? Now, when is the distance going to be greatest? How do you find the greatest value for any function? Greatest value for any function? How do you find that? When the derivative of that function is equal to 0, right? So what we can do is, let's call this something, let's call this d. We find d dash, that will be 10 minus 2t minus 6t squared plus 18t. There's something wrong there. 10t minus t squared. Let's actually simplify that first before we differentiate. I'll just simplify this a little. 10t plus 8t squared minus 2t cubed. This is d. Let's differentiate it. Find the derivative of this. 10 plus 16t minus 6t squared. You find the derivative and you put that equal to 0. So you get 0 equals 10 plus 16t minus 6t squared. Now, what do we get from that? This is a quadratic function. 6t squared minus 16t plus 10 equal to 0. Can we factorize this? We could simplify this first or just input values in the quadratic formula. That's also fine. But in this case, is factorization possible? Yes, we can do that. 3t squared minus 3t minus 5t plus 5 equal to 0. We get two factors from this, 3t minus 5 and t minus 1. So t is either equal to 5 over 3 or t is equal to 1. T is equal to 5 over 3 or t is equal to 1. These are two possible values of t that we're getting. Okay. Now, there are two possible values that we're getting. How do we know at which one we're going to have the maximum value? One is 1 and the other is 5 over 3. 5 over 3 is 1.67. Okay, 1.67 is going to be somewhere here. 1 is going to be somewhere around here. Okay, it could be at both of those points. Maybe it's maximum at both, or maybe it's minimum at one of them. What we can do is we can just input both of them. Input both of them in that distance function and see what values they give us. I think at both of them, we might end up getting the same value. Let's just try that. D equals 10 into 5 over 3. You could check using the second derivative as well if you wanted. But let me just input values and see what that gives us. 10 into 5 over 3 plus 8 into 5 over 3 whole squared minus 2 into 5 over 3 whole cube. You'll get some value from this. You input t equal to 1 and see what that gives you. 10 into 1 plus 16 into 1 squared minus 2 into 1 cube. And that will give you something. Let's see what these values turn out to be. 10 into 5 over 3 plus 8 into 5 over 3 whole squared minus 2 into 5 over 3 whole cube. Okay, now that's giving me 800 over 27 or 29.63. Okay. Do we need to check for return journey? We're not talking about distance traveled in this case, right? That is required when we're talking about distance traveled. Here we're just talking about a specific position of the particles. So that doesn't matter. Okay, let's see what we get at 1. 10 plus 16 minus 2, and that's giving me 24. Is that correct? 10 plus, actually, I'm inputting in the wrong function there. On the correct function, that's okay. 10 plus 16. I have put this in the wrong function. I'm sorry. 10 plus 8 into minus 2 into that. What will this be? This is 10 into 1 plus 8 into 1 squared minus 2 into 1 cube. And that is giving me 18 minus 2, which is 16. Now, this is the greater value. Let me just verify that as well. 10 into 5 over 3 plus 8 into 5 over 3 whole squared minus 2 into 5 over 3 whole cube. And that was giving me this 800 over 27. So it should be one of these two values. Now, why are they turning out to be different? Let me just check my working again. Between 0 and 5, they're both points in between 0 and 5. We had the velocity of q that was 10 minus 2t. We had the velocity of p that was 6t squared minus 18 times t. Velocity functions are fine. 10t minus 2t squared over 2. That gives me 10t minus t squared, which is okay. And then 6t squared minus 18t, 60 cubed divided by 3. And that gives me 2t cubed minus 18t, 18t squared over 2. That's 9t squared. Okay, this is fine. Then I subtracted them. 10t minus t squared minus 2t cubed plus 9t squared. 10t plus 8t squared minus 2t cubed. And that gives me 10 plus 16t minus 6t squared. Okay, this is what I'm getting. Now, was there a problem? Okay, the answer is different there. Let me just check the working for this again. 60 squared minus 60. Okay, I'm sorry, I made a careless mistake there. This was minus 10 there, right? This was supposed to be minus 10. I put plus 10 there. Okay, I'm sorry, there was an error there. Let me correct that. Acha. So at this point, 10 plus 16t minus 60 squared, that is equal to 0. We take everything to one side, and that gives us 60 squared minus 16t minus 10 equal to 0. Now we divide by 2, and that gives me 3t squared minus 8t minus 5 equal to 0. Can we factorize this now? This cannot be factorized, so we have to input values in the quadratic formula. Minus into minus 8 plus minus square root of minus 8 whole squared minus 4 into 3 into minus 5 whole divided by 2 into 3. You should show this one single step. Then you can write down the answers after that. Let's see what this turns out to be. Menu, equation, polynomial, degree 2, input values there. 3 minus 8 minus 5. Okay, the two values of t that I'm getting from this are 3.189 and the other value of t is negative. Okay, so t equals minus 0.5226. Okay, one is negative, so time cannot be negative. This is clearly not possible. There's only one value of t that we get from this. Put that back in that distance function, and that will give you the corresponding distance. You can see what that is. 10 into 3.189 plus 8 into 3.189 whole squared minus 2 into 3.189 whole cube. And that should give you the value for that greatest distance. You can see what that turns out to be. 3.189, 10 into answer plus 8 into answer squared minus 2 into answer cube. And that gives me 48.385. To three significant figures, that becomes 48.4 meters. That's the final answer that we get. This is what we were looking for. So whenever you are looking for the greatest or least value of anything, what you do is you find the derivative of that function and you put that equal to 0. That's what we did. We found the derivative and we put that equal to 0. Okay. Now, since the derivative is going to turn out to be the same thing, you could just subtract these velocity functions directly as well. You could subtract the velocity functions directly as well. And because that's the derivative of both displacements, right? We could subtract them, put that equal to 0. That's exactly what we're getting here in any case. However, you would still need this function because we have to input a value of t back in this function eventually. How do we know? We have to find the distance or the difference between them. They're asking you for the greatest distance between P and Q. Now, What we have done is we have found their displacement functions. When would we have the maximum distance between them? When the displacements between them would have the greatest difference. Displacement tells you the position of the particle at a particular instant, right? So all we are doing is we're saying, let's subtract these two numbers. Subtract these two numbers. That gives you the distance between particles at any instant. This difference. Now, since you want to find the maximum value of this distance, maximum value of any function, how do you find that? You find the derivative of that, put that equal to 0, and that gives you the maximum value or the minimum value. In this case, we're only getting one t value. So it's fair to assume that that is going to give you the maximum value. Makes sense, right? Okay, chale. Let's move on to the next one now. Those of you who are still here, what if we subtract P from Q instead of Q? You could try the other way around. It'll just turn out to be negative at the end. You could see on the graph, the velocity of Q is positive. The velocity of Q is negative. So the maximum distance is going to be somewhere in this region, most likely, right? So you can see Q is moving in the positive direction. That's why I subtracted P from Q. If you do it the other way around, that is still okay. The only thing that would change would be you would end up with a negative value here. But since you're just looking for distance between 2 points, it doesn't matter if it's positive or negative. The final answer that you would write, you would just write that as positive. Okay, chale. So let me show you the solutions for the remaining questions now quickly. Saad has been asking about this repeatedly. Let me answer that quickly. Uh, November 25. November 25, paper 4-3, question 6. Achha, I'm going to show you the solutions for some more questions now. The detailed workings for them, you will find them in some videos that I'll be posting in the next 12 or so hours, inshallah. Let me show you the solution. Okay, both now it will be relatively quicker because I'm just going to explain the solutions that are already done because most of these questions I have them solved already. Acha, what was that? November 25, paper 4-3. Let me go to that quickly. November 25, paper 4-3, question number 6. Okay. Can you guys be a bit specific about the parts that you have problems in? So that makes the process a bit quicker. Or the specific confusion that you have, so maybe I can address that specific confusion, right? If you have a specific confusion, you can tell me about that, and that might make things a bit quicker, okay? Achha, now they're saying particle P of mass m kilograms and particle Q of mass 2 kilograms. They are free to move on a smooth horizontal surface. They're moving towards each other. We have their speeds given. The direction of motion is reversed by the collision. Immediately after collision, the speed of P is u over 3. We need to find an expression for the velocity of Q after the collision. Okay, so first of all, how do you find an expression for velocity of Q? These are initial velocities. P is moving towards Q, Q is moving towards P. So initial velocity for P will be U, for Q it will be minus 3U. After collision, their directions reverse. That means P is going to go to the left side at a speed of U over 3. What about VQ? We don't know that. So all we have to do is apply conservation of momentum, input values in that, and VQ turns out to be this number. This is VQ. Okay, that's the first thing we do. Okay. That's straightforward, right? We just apply conservation of momentum. We just apply conservation of momentum. Acha, now, once that is done, They're saying hence show that m is greater than 4.5. Now, how do we do that? How do we show that m is greater than 4.5? Do we have any information given in the question? The only thing that they tell us is that the direction of motion of each particle is reversed by the collision. Now, if you're taking right side positive, which direction should Q move in after collision? Which direction should Q move in? Q should move towards the right side. Q should move towards the right side. If its direction reverses, what that means is VQ must be a positive number. So this expression that we're getting, it has to be a positive number because Q is supposed to move to the right. So we just put that number greater than 0 for that reason. U gets cancelled because every term has U that gets cancelled, and we get M greater than 4.5 from that. Okay, makes sense, right? ठीक है. So that's the first part. Then they're saying in the second part, Q subsequently hits a vertical wall, which is perpendicular to the direction of motion of Q. The speed of Q after the impact with the wall is a quarter of its speed before the impact with the wall. There are no further collisions between P and Q. Given that M is an integer, determine the largest possible value of M. Okay, now after that first collision, what has happened is P is moving to the right at this speed. Q is moving to the P is moving to the left at this speed, and Q is moving to the right at this speed. Now, what happens is Q collides with a wall here. Q collides with a wall, and then returns at a speed that is one quarter of its initial speed, of its earlier speed. So it hits at this speed, comes back at one fourth of that. Okay, so now Q is going to move to the left at this speed. P is moving to the left at this speed. Now they're saying there are no further collisions between P and Q. There are no further collisions. Now, if there are no further collisions, think about it. Let's suppose if P was moving at 6 meters per second to the left and Q was moving at 10 meters per second to the left. Will there be a collision between P and Q? Yes, Q will eventually catch up with P at some point and there will be a collision. So if Q speed is greater, there will be a collision, right? What if they're equal? What if both of them are moving at 6 meters per second? Then there will still not be a collision because they will keep moving at the same velocity. The distance between the particles, that is going to remain the same. That's not going to change. And they will never collide in this case as well. When will there be no collision? When the speed of P is greater than the speed of Q. So for example, if it is 5 meters per second to the left, then Q will never be able to catch up with P. That is what we do here. We say, for there to be no further collision, U over 3, that must be greater than or equal to this number. Then there will be no collision. If it's equal, then they will keep moving at the same speeds, but never collide. Or if P is greater, the speed is greater, in that case as well, Q will never catch up with that. So U over 3 is greater than or equal to this. Every term has U in it. That gets cancelled out. U is a positive number, so we can cancel that out in an inequality as well. Simplify that, we get M less than or equal to 6.5. They told us that M is an integer. If M is an integer, what's the largest possible value of M? Less than equal to 6.5, the largest M would be 6, and that's our final answer. So if there's no further collision, what that means is the velocity of P that must be greater than or equal to the velocity of Q. Okay. S2, unfortunately, I haven't started teaching S2. I plan to do that soon, inshallah, but unfortunately, I didn't do that right now. So No. Acha. What about the next one now? November 25, paper 4-2, question number 4. Acha, I'm sorry. So there's one person up who has been asking for quite a while. Uh, Omar, yes. Question 5, paper 4-3, November 22. November 22. Question 5, paper 4-3. Paper 4-3, question number 5. November 22, paper 4-3. Yeah, that's the same paper. It's not solved here. November 22, 4-3, question number 5. Acha, particles x and y, they move in a straight line through points A and B. Particle x starts from rest at A, move towards B. At the same instant, y starts from rest at B. Okay, so we've got these 2 points, A and B. They're saying x starts from rest at A, moves towards B, and y starts from rest at B. At time t seconds after the particles start moving, acceleration of x in the direction AB is given by this 12t plus 12, and acceleration of y in the direction AB is 24t minus 8. It's given that the velocities of x and y are equal when they collide. Calculate the distance AB. Okay, now how do we think about this? We've got their acceleration functions, right? Acceleration function for one of them, that is 12t plus 12. For the other one, it's 24t minus 8. We've got the acceleration functions of both of them, right? Now, what we can do is, using those acceleration functions, we can find the corresponding velocity functions. How do we do that? We integrate the acceleration function, and that gives us the velocity function. Now, remember, whenever we integrate, we always have a plus c. We always have a plus c. Whenever we integrate, we always have a plus c. The only exception is when we have limits involved. And that is generally when you have to find displacement value from one point to another. In this case, we're not doing that. So we have a plus c there as well. Now we know they both started from rest. They both started from rest. Since they both started from rest, we can say when time is 0, velocity is 0. And for that reason, the c values are going to be 0. Okay, so you should always consider that plus c. Okay, you should always consider that plus c. Okay. All right, now we've got the velocity function. They are saying when they collide, the velocities of x and y are equal. Now, what we can do is we can find that point at which the collision happens. How do you find that? We put the velocities equal to each other. Put the velocities equal to each other because they told us at the point of collision, their velocities are equal to each other. So we put the velocities equal. That gives us an equation. We solve that equation and that gives us time equal to 0. That's not interesting because that's just the initial point. And time equals 10 over 3. So the velocities are equal again at time equals 10 over 3. That is when the collision happens. So now we've got that time instant when the collision happens. All we have to do now is find the displacement of both the particles from 0 to that point, from 0 to 10 over 3. Just find that displacement and see what that turns out to be. So we have the velocity functions, right? Integrate them from 0 to 10 over 3. Integrate them from 0 to 10 over 3. For x, it turns out to be this number. For y, it turns out to be this number. Okay? So A is moving to the right by some distance, B is moving to the right by some distance because they're both positive values. That means they're both moving to the right. So initially, they were actually both moving to the right. Okay, because the acceleration for Y was also positive, so it should be moving to the right as well. So they both are moving to the right. Now, how do you find the distance from A to B? 2800 over 27 is the distance traveled by B. This is the distance traveled by A. If they meet at this point, what is AB going to be? The difference of those two values, and that gives you 1000 over 27, which is 37.04. That's your final answer. Does that make sense? Right? Why not check for return as well? Again, we need to check for return only when we're talking about distance traveled. Distance traveled. We're not talking about distance traveled in this case. We're not talking about that. Okay. We're not talking about distance traveled. Okay. Acha. Now, and then they're saying it's given that AB is equal to 36 meters. It's given instead. Okay, so whatever we did in the first part, that's not relevant anymore. Now they told us the distance AB is 36 meters. Okay. Verify that X and Y collide after 3 seconds. Now, what do we do for this? You can again find the displacement for both of them. Find the displacement for X, find the displacement for Y from 0 to 3 seconds. See what that gives you. Their difference will be 36. So displacement for X, that is 108. Displacement for Y, that is 72. If their difference is 36, that means AB is equal to 36. And that proves that they collide after 3 seconds. Okay, because if one of them is moving 108 meters to the right, this is 108 meters, and the other is moving 72 meters to the right, then what's the distance AB then? That is 36. That's what we wanted to figure out. That after 3 seconds, there's a collision. ठीक है. All right. अच्छा, अभी तक इसका कोई क्वेश्चन आंसर नहीं हुआ. हमजा और तौसीफ. Okay, let's do these two now. November 4-3, question 5. November 4-2, question 4. Okay. Sure. November 25. November 25, right? 4-3. Question number 5 from this. Okay. Particles A and B of masses 2 kilograms and 6 kilograms respectively. They are attached to the ends of a light and extensible string. The string passes over a smooth pulley. The particles hang vertically below the pulley. Both particles are held at rest initially. A is projected vertically downwards uh, with a speed of 1.2. The first part is just acceleration and tension. That's a standard part. Just apply Newton's second law of motion on both the particles, and that will give you the value for tension and the value for acceleration, right? Now they asked you for the magnitude of acceleration. The actual acceleration value is turning out to be -5, but you'll say the magnitude therefore is +5. If you write -5 there, you lose a mark. Magnitude means you are supposed to ignore the negative sign. Okay? ठीक है. अच्छा. Now, the first part is straightforward, right? That's not what you have problem in, I hope. We just represent all the forces weight acting downwards for both of them, tension acting upwards for both of them, and then we just apply Newton's second law of motion in both of them. Right? That's how you do it. The next part says, in the subsequent motion, A does not hit the ground and neither particle reaches the pulley. When B hits the ground, it does not rebound. Find the time that B is in motion. So B hits the ground at some point. How much time does it take to hit the ground? We know it started from, no, A was projected at 1.2, so the initial velocity for B is going to be 1.2, right? So now what's happening is A does not hit the ground, and then B hits the ground at some point. Okay. Now notice how the journey is going to be like. Initially, what happened was A was projected in the downward direction. So A was pulled down. A was pulled down. Even though the weight of B was greater, so if they were released from rest, B would have gone down, but they pushed A in the downward direction at this speed 1.2 meters per second. They're saying A does not actually hit the ground. A does not hit the ground. If it does not hit the ground, what would happen would be it would go down for a while, reach its lowest point, and then it'll start going upwards. Why? Because B has greater weight. So B, on the other hand, is going to go up for a while, and then it's going to try, then it is going to start going downwards after that. That's what the journey is going to be like. We want to find the time taken by B to hit the ground. Now, how can we do that? We know the initial velocity for we know the initial velocity for B, that is 1.2. That's the initial velocity for B. We can use that. Initial velocity is 1.2. Acceleration, if we take upwards positive for B, if we take upwards positive, I'm taking upwards positive here for B. Acceleration for B in this case is going to be -5. Why is that? Because the downward force is greater, right? Downward force is greater. Since the downward force is greater, we found in the first part, acceleration was negative. Okay. So we know initial velocity is 1.2. Acceleration is -5. B was at a height of 3.2. Since we are considering upwards direction positive, it its displacement is going to be -3.2. So from this initial point, all the way to the ground, what's the displacement? Remember, when we talk about displacement, we don't care what happened in the middle. We just care about the starting point and the end point. The end point is below the starting point. How much? It's below by 3.2 meters. So the displacement for B, therefore, is going to be -3.2 meters. That's the displacement for B. Okay. So we input that value. Displacement is -3.2. Find the time taken from that. S equals ut plus half at square. This is the value that you end up getting from that. Make sense? Okay. Okay. That's the second part. Now they're saying find the distance between the lowest and highest points that A reaches. Okay, now, first of all, A goes in the downward direction. What I like to do is I like to label these points because that helps us show everything correctly in the working. And the examiner will understand what you're doing as well in that case. So I've labeled these points like this. I'm saying this point where A started its journey, this is X. The lowest point that it reached, that is Y. Why we did not take it from maximum height? Because the starting point was this, right? End point was this. What is displacement? Displacement is the shortest distance from the starting point. So we don't care what happened in the middle. It went up, it went down, doesn't matter. We just care about what was the position in the beginning and what was the position at the very end. That's all that we care about. Okay? That's how we find displacement, right? What we know in the initial eh, at the very beginning and what we know about the very end. Acha. So what I'm saying is, let's call this point X, where the particle starts its journey. Then the lowest point is Y. Then the journey is going to be like this, that it reaches that lowest point, then it comes back to X, and then it goes up for a while until point Z. Z is that point where the string becomes slack. Why? Because that is when B hits the ground. Now, how much distance would that be? From the initial point, this would be 3.2 meters above. Why? Because B was at a height of 3.2 meters. So when B goes 3.2 meters down, A would have gone 3.2 meters up. Now at that point, they're saying B does not rebound. If B does not rebound, the string is now slack. So it is going to move in free fall for a while from Z to M. M is the maximum point reached by the particle. So there are multiple parts of this journey now. What we're looking for is the distance between the lowest point and the highest point. So basically the distance from Y to M. That's the distance that we're looking for. Now, we already know the distance xz, right? X to z is 3.2 meters. That is something that we know already. X to z is 3.2 meters. The problem is x to y and z to m. Those are the two that we're looking for. Okay. Let me come back to that. Come back to your question. Let me just complete this first. Achha, now, so we want to figure out the displacement from x to y and from z to m. That's what we're looking for. Now, how do we do that? In the first part of the journey from x to y, that is when the string is start. What do we know about this part of the journey from x to y? Let's focus on this, the left side here. The particle is going in the downward direction, so we take downwards positive for that. Initial velocity we know is 1.2. Acceleration, -5. Final velocity is 0. When it reaches the lowest point, it's going to come at instantaneous rest, right? When it changes direction. So we know initial velocity, acceleration, and final velocity. What we can do is we can find displacement from that. That turns out to be 0.144. So the lowest point is going to be 0.144 meters below the starting point, below the initial point. That's what you figure out. Okay. Achha, then it starts going up from that point. It starts going up from that point. Now from the lowest point to the point Z, the string remains taut. What do we know about this part of the journey now? From Y to Z. From Y to Z, we know the initial velocity. What about acceleration? What about acceleration? Now we consider upwards positive because it's going in the upwards direction, right? So we can take upwards positive now. When we take upwards positive, acceleration in this case is going to be positive. Okay. If you keep downwards positive, you can do that as well. You can keep downwards positive. In that case, you would take acceleration equal to -5, but then the displacement would be negative as well in that case. So it depends on the positive direction that you take. Since from Y to Z, it's moving in the upwards direction and we are breaking the journey at this point, I'm saying let's consider upwards positive. If we consider upwards positive, we can say at Y, the initial velocity was 0, acceleration is 5. What about the displacement from Y to Z? We know this distance from X to Y is this, from X to Z is this. So the total displacement will be the sum of these two numbers. Now, why do we need this when we already know the distance traveled in this part? We want to find the final speed at this. Why? Because that is what we will use in the next part of the journey then. The final speed of this part will become initial speed of the next part of the journey. So for y to z part of the journey, we know three things. We can find the final velocity from that. Now, this final velocity becomes the initial velocity for the next part of the journey. Okay. Now, from z to m, we know initial velocity is 5.78. That's the final velocity for the previous part. And now the string is slack. It's free fall. If you're taking upwards positive, acceleration is going to be -10. At the maximum point, final velocity will be 0. So we have the initial velocity, acceleration, well, final velocity input in this equation. You get the displacement value for that. That's the displacement from z to m. So now we know z to m distance as well. We want to find the total distance between the lowest point and the highest point. We add up these distances, and that will give us the distance between the lowest point on the graph and the highest point on the graph on that diagram. Add up all of those values, and that turns out to be 5.02. That was very tricky, but that's how you'd approach this. ठीक है? अच्छा, let me answer your question. What do we take as initial velocity for B in the previous part? In kinematics questions, always think about what you're taking as your positive direction. So in that part, for B, I took upwards positive for B because it was going upwards and then coming down after that. If upwards is positive, then the initial velocity is 1.2, right? B is going upwards at 1.2. That's the initial velocity. Initial velocity is 1.2, positive 1.2. Acceleration is -5 and displacement is -3.2. These are the values that we take for that part. Okay. Nowadays, questions are easy. Are you sure about it? Earlier, the questions actually got pretty repetitive at some point, but now they give one question at least in every paper that requires you to think a lot, sometimes more than one as well. ठीक है. अच्छा. November 25, paper 4-2. Question number 4. Okay. Chalo, let's do this. A particle P of mass of 0.1 kilograms is projected vertically upwards with speed 30 meters per second from horizontal ground. At the same instant, a particle Q of mass 0.4 kilograms is projected vertically upwards with speed 10 meters per second from a height of 15 meters above the ground. P and Q move on the same vertical line. Find the height above the ground at which we've already done that. We've already talked about this before. The second part as well. Yeah, Tosif, did you ask about this earlier as well? We have discussed this. So go back in the stream. Go back in the stream. We'll find that. Yes, Tosif, nothing changes in horizontal or vertical. It works the same way. Just be careful about the positive direction. So if you're taking upwards positive in conservation of momentum, anything that's moving downwards, you'll take that velocity as negative, but everything else works the same way. Okay. Uh, I get so many messages. I'm really sorry. It's very hard to see all of them. So if it's from an unknown number, it takes time to respond. Takes time to respond. You're welcome. I hope Your exams go well, inshallah. Make sure that you make dua for me after that. You found an error in part B of question number 5. Walaikum assalam. June 25, paper 4-3. What's that error? June 25, paper 4-3, question number 5. June 25, paper 4-3, question number 5. What's the error in this? In the marking scheme? What does the marking scheme say? Acha. Okay, I'll just show you the solution if in case you want to take a snapshot of this. June 25, paper 4-3. And this. Okay, acha. If you make A the subject of the formula in both equations, theta is 4.7. It can't be. You can try that. There must be some careless error that you're doing. You can check for that in your working. So whatever way you solve this, as long as you're getting the same equations, you should get the same result eventually. So maybe try figuring out any error in your working. March 26, I've posted that solution publicly as well. You can have a look at that. March 26, I've solved that whole paper. That's not a very difficult paper, वैसे. अच्छा, question 5, June 25 paper. चलो तो वही है. November 22 paper 4-3. Okay, November 22 paper 4-3. Which question? Last part of which question? You can send it to my number that's on my Insta. Math with Ahmad Bilal. Search for that username. You'll find a number there. WhatsApp is connected there with Insta. Which question from this, Hamza? This we've already discussed before in the same stream. Hamza, what's the question number that you're talking about? Hamza Irfan. Cambridge does not say anything about the leak yet. We'll have to wait for their update on 7th of May, inshallah. That's just a couple of days away now. Hamza, I'm still waiting for a response if there isn't any. November 22, paper 4-3. This is the correct paper, November 22, paper 4-3, question number 7, last part. Okay. All right, so we have particles of masses 1.5 kg and 3 kg. They lie on a plane which is inclined at an angle alpha to the horizontal, where tan alpha is 3 over 4. The section from A to B is smooth, and the section from B to C is rough. Show that the coefficient of friction of the part between the particle at B and the plane is 0.75. Okay, so you don't have a problem with that. Then what happens is it's released from rest. In the subsequent motion, the two particles collide and they coalesce. The time taken for the combined particle to go from B to C is 2 seconds. Coefficient of friction is still 0.75. Okay, so you don't have a problem with this as well, although B looks a bit tricky. The final part you're saying, find the total loss of energy of the particles from the time the 1.5 kg particle is released. Okay, now when the 1.5 kg particle was released, what was the energy? What was the total energy? We are looking for the loss of energy, right? Loss of energy. Now, what was the initial energy of both of them? mgh, mass for A is 1.5 into g, that is 10, into height. How do you figure out the height? We can make a triangle like this, right? We've already found the value for x in the previous part somewhere. Yeah, that was 3. So we know the value for x now. You make right angle triangles, you know that this is 7. The angle is known. You can use that to find the height of A. So HA over 7 is equal to sine alpha. Similarly, HB over 4 is equal to sine alpha. That gives you HA and HB. You were given the value for tan alpha in the question. Using tan alpha, you can find sine alpha and cos alpha. Just input their values there. You'll find the initial energy, mgh for A, mgh for B, or for the 1.5 kg particle and the 3 kg particle. That's the initial energy. And then at the end, when the combined particle reaches this point C, potential energy, if you consider this ground level, that will be 0. So you just have to consider the kinetic energy for that. What would that be? Half mv squared, half into mass, which is 4.5, the sum of the two masses, into velocity at that point. We find that in the previous part somewhere. It was 2. Let me see if I can find that somewhere. For the combined particle at the point C, do we have that anywhere here? Oh yeah, so we found that here somehow. I'll have to go through the whole question again, but we have found that in the previous part somewhere. So you just use half mv squared, and that gives you 9 joules, and you find the loss then. That's pretty straightforward, the last part. Okay. Shouldn't the loss be 9 joules only? 9 joules only. Why? Because initial is this, final is this. Loss is going to be their difference, the difference between those values. So find the difference between them. 9 is the final energy. 9 is the value for the final energy. Loss will be their difference. Okay. Matina explained that earlier in the circle question, yes, in the same stream. Uh, November 25, paper 4-2, question 6. November 25, paper 4-2, question number 6. We are almost ending now. I haven't had dinner yet as well. I'll need to go. Yes. I'm not sure what you mean, Tausif. What exactly are you asking about? They're saying find the distance the particle travels from O. They're talking about distance traveled. Whenever they talk about distance traveled, you have to check for this. You have to check for change in direction. So, yes, you do have to check for change in direction. अहमद, आप M1 पढ़ रहे हैं अभी? Tausif. So, yes, we do have to check for change in direction in this, if that was your question. All right, Chale. I think we will end this here. I'll have another session tomorrow as well in case there are any more questions, but I will be posting a lot of videos before that as well. Difficult questions from the last 2 years. You'll already find difficult questions videos from the previous years, from 2020 onward. In the difficult questions playlist, M1 playlist, we'll find that there. But I'll add to that as well. That's only for the people who are expecting an A or an A star, inshallah. If you're expecting less than that, you better spend time on revision, revising the concepts that you've done. For that, use the revision videos that I've posted. They may be helpful as well, inshallah. Okay, that's it for today then. I'll see you again tomorrow, inshallah. Allah Hafiz. अच्छी बातें करें, लीक्स की बात नहीं करें. इंशाल्लाह नहीं होगा. इब्राहिम. It's okay, just make sure that you manage time well. Time management आपने सही करनी है, and you should be fine, inshallah. Just make sure that you're managing time well. Okay, चलें. I'll end this here. I'll have to leave. It's pretty late now. 7B में क्या है? 7B में क्या है? The resultant should be used from you. So, what's the question? Yes, most likely you're supposed to use F equals ma here. And that's what it looks like initially. And then use constant acceleration as well. Yes, so you have some forces given. You have some forces given, and you are supposed to use this information about distance traveled, time as well, right? So some quantities are from kinematics, some quantities are from forces. Newton's second law of motion is the bridge between forces and kinematics. So that's what you'll have to use here. Newton's second law of motion. When do you have to use F equals ma? When you have some forces and some and some kinematics quantities, the Newton's second law of motion is the bridge between them, right? That connects those two topics, forces and kinematics. So you've got forces here, you've got some information about kinematics, distance traveled, time taken. F equals ma is going to connect both of them. So yeah. Okay, Sharon, that's it for today then. I'll see you again in the next session, inshallah. Allah Hafiz. You're all welcome. Make sure that you just remember in du'as. Uh, make a lot of effort over the next day as well, inshallah. You can still improve a lot wherever you are at right now, inshallah. Make these last 36 hours count.